So we're working with the law of sides. In our last video we had, let's see, two angles and one side. And now we have two sides and one angle. We have little a is 5, little c is 2, and a is 35 degrees. Let's draw a generic picture, not very accurate necessarily, but let's do it. Here's a, b, c, a is 35 degrees. Now let's do little a, little b, little c, little a is 5, little c is 2, and the rest are unknown. So I can't immediately try to find the B and C right off the bat based on them adding up to 180 degrees because I only got one angle. If I had two angles, I could find the third radius. So what we could do then, well, we could actually find big C, because if you think about it, I have big A, little a, and I have little c, so I have those three, so that can allow me to find big C using the law of sines. So let's find big C. So I'm going to have that the sine of big C over little c, which is 2, is equal to the sine of big A, which is 35 degrees, over little a, which is 5. So to solve this, the first thing I'll do, I'll take the 2 up top on the right-hand side. So I'll get sine of c equals 2 times the sine of 35 divided by 5. Now, here we want to get c by itself, right? We're trying to solve for c, so I'm going to get rid of the sine on the left-hand side. And I'm going to bring it to the right-hand side. It's going to become the sine inverse. So I'm going to get c is sine inverse of 2 sine of 35 degrees over 5. So c is, so in my calculator, to get the sine inverse, I'm going to hit the second sine. And when I press second sine, that should give me the sine inverse. And inside the sine inverse, I'm going to press 2 multiplied by sine of 35, close parentheses, divide by 5, and I get 13.26, approximately. Oh, but this is an angle, so I'll just say 13.3. 13.3. I'll stick to one decimal place when I'm dealing with angles. So 13.3 degrees. So once I got that second angle, now I can easily find the third angle, big B, by making sure they add up to 180. So I'm going to find big B. So I'm going to say, let's see, 35 degrees, which is A, plus 13.3 degrees, which is C, plus big B, equals 180. If I do 35 plus 13.3, that's going to give me 48.3 degrees plus big B equals 180. So big B, we subtract 48.3 from both sides, we get 180 minus 43.3. So big B is, let's see, 180 minus 43.3. Okay, so that's 136.7. And really that's approximate because we approximated earlier. Remember, we approximated C was 13.3, so it's really approximate because we're relying on the fact that C is approximately 13.3. This is not to scale this triangle, not at all. So B is 136.7 degrees. So you can see I didn't draw the triangle to scale or anything because that angle obviously is not appearing to be 136.7 degrees. It's much smaller. I mean, 136.7 is like obtuse angle, and I got an acute looking angle. But I mean, your pictures don't have to be accurate. Mine's not accurate. Okay, so we got big C, big B. The only thing we have left is little b, right? Little b, this guy right here. So to find little b, well, I'm going crazy. My screen doesn't want to cooperate. There it goes. And use this law of sines where we have sine A 35 degrees over little a 5 equals sine of b 136.7 degrees over little b. And we can pull the little b up here on the left. We can pull the sine of 35 under the sine of 136.7, and we can pull the 5 up top with the sine of 136.7. So we get little b is 5 sine 136.7 degrees over the sine of 35 degrees. So we'll approximate b, since it's a length of 2 decimal places, 5 times the sine 136.7 divided by the sine of 35. It's going to be about 5.98. 5.98. Okay. So with that one, we had, let's see, 2 sides and an angle. This would be a number 3, I guess. Number 3, we're going to do 2 sides and 2 angles and a side. Okay. Here I have b equals 4, a equals 115, and capital B equals 40. So 1 side and 2 angles. Let's just draw a generic picture. Probably not very accurate. I got A is 115. I got B here is, I like to put B over here as 40. C is unknown. We got little a, unknown. Little b is 4. Little c is unknown. So first things first, we can find big C, since we got 2 of the angles, right? So these have to add up to 180 degrees. So I'm going to have 115 plus 40 plus big C equals 180 degrees. So 115 plus 40 is 155 degrees plus C. That's going to be equal to 180 degrees. So subtracting 155 from both sides, I get 180 minus 155. And I get C is, let's see, 180 minus 155. 25 degrees. Okay, so next thing's next. I'm going to find, let's find little a. Using the law of sines, so I know that the sine of big B, 40 degrees, over little b, 4, is equal to sine of big A, 115, over little a. So cross multiplying, I bring the little a up on the left, I bring the sine of 40 under the sine of 115, and I bring the 4 up in front of the sine of 115. So I got a is 4 sine of 40. And since we're dealing with a length, we'll go to 2 decimal places, approximating in our calculators 4 times the sine of 115, close parentheses, divided by sine of 40. Got 5.64 approximately. All right, let's find little c. Using the law of sines, I can say that the sine of big B, 40, over little b, 4, is equal to the sine of big C, 25, over little c. Cross multiplying, I bring the little c up top on the left, bring the 4 up top on the right, and the sine of 40 down fold on the right. So I get on the right 4 sine of 25 divided by the sine of 40. And this is a length. We're going to take it to 2 decimal places approximately. Approximate to 2 decimal places, I should say. That's 4 times the sine of, is that 25? 25, close parentheses, divided by sine of 40. I get about 2.63, approximately, 2 decimal places. Keep in mind this is not to scale, it's not intended to be an accurate picture. All right. I'm gonna make sure I do a cool word problem. Where's my word problem? This is a number 4. Goes something like this. Let's see if I can read. Maybe I'll do this in the next video.